All right, so we've spoken about antiderivatives, and now what we're going to do is try to do this on our own, and we're asked to find all of the functions g such that g prime of x is equal to this expression here, 4 sine x plus 2x to the fifth minus the square root of x over x. I'd encourage you to pause the video and do it on your own, but once you're done, you can hit play, and now I'm going to walk through the solution here. So the first thing that I would probably do is separate this back component because it's really two fractions, and what I want to try to do is get this to where I can apply the reverse power rule. And right now I would have to try to figure out some sort of reverse quotient rule to do this, and I don't want to have to do that. So I'm just going to separate that into two different fractions there. So g prime of x is equal to 4 sine of x plus, and I'm going to call this 2x to the fifth over x minus the square root of x over x. And x to the 1/2 is the same thing as the square root of x. All right, and now I'm going to remember that if I have the same base of two terms in a fraction, I can just subtract their exponents. So this is x to the fifth minus, or x to the fifth divided by x to the first, so all I have to do is 5 minus 1 to get that exponent. So that's the same thing as 4 sine of x plus 2x to the fourth, because 5 minus 1 is 4, minus, and 1/2 minus 1 is going to be negative 1/2. So now you can see this is just a better way to look at this. All of this is all of this. I haven't calculated any antiderivatives or anything like that. I'm just rewriting g prime of x. But now I can take the derivative, or the antiderivative rather, of each of these components by just sort of asking myself what function has this as its derivative. So 4 sine of x, what function, if I took its derivative, would give me 4 sine of x? And so since this 4 is a constant, I sort of just have to think about what function has the derivative sine of x, and I can just add that 4. All right, because we know these trig functions just cycle. So which function has the derivative sine of x? And the answer is negative cosine of x. So this is going to become negative 4 cosine of x. And off to the side, it wouldn't be a bad thing to just kind of test this. What's the derivative with respect to x of negative 4 cosine of x? Number of ways you could do this, but if you wanted to look at it as cosine of x on its own, the derivative of cosine is negative sine. So this would become negative 4 times negative sine of x, and those negatives would cancel, and I'd have negative sine of x, or positive 4 sine of x. So this does get me my original 4 sine of x, so that'll work. I'm just going to move some of this out of the way here. All right, so we did our check. Now we can go back and deal with these other two terms. 2x to the fourth. Well, if I go backwards and take the antiderivative, it's going to have to be an x to the fifth, right? Because when I take that derivative, the 5 comes down and becomes a 4. But when that 5 comes down, I need it to somehow become a 2. So what could I put here in this space that when the 5 comes down, all that will be left will be a 2? Well, what I'm going to put there is a 2, because I need that 2 to be there, but I need the 5 to come down and then disappear. So I'm going to divide this whole thing by 5. So if I want to do a little check right now for myself, I can test that. What's the derivative with respect to x of 2x to the fifth over 5? Well, that 5 is going to come down. So that's going to be 5 times 2 times x to the fourth over 5, and that's where you're going to see those 5's cancel, and you'll just be left with 2x to the fourth. So we've done our check, and now we can finally do this last term. What's 1 greater than negative 1/2? Positive 1/2. All right, so when that positive 1/2 comes down, it all ends up having to cancel to leave behind a negative 1. So what I'm going to do is use a subtraction sign here, And again, I'm going to divide by that exponent because when that exponent comes down, I need it to cancel. And so I could do a little check here and just see what will happen in that case. The derivative with respect to x of x to the 1/2 over 1/2. The 1/2 comes down. Now I have x to the negative 1/2. But since it's all being divided by 1/2, those will cancel. And so I will be left with just x to the negative 1/2. And if I put that subtraction sign in front of it, then I get my negative x to the 1/2. All right. So now it's just a matter of simplifying this a little bit. I'm just going to rewrite it. G of x equals negative 4 cosine of x plus, I prefer to write my fraction in front there, but you can write it however you'd like. And then lastly, when I divide by 1/2, that's the same as multiplying by 2. So I'm going to write minus 2x to the 1/2. There is a part of this that I'm forgetting here, and it does say to find all functions. So when you find all functions, you have to remember, and I haven't left myself a lot of space, but you have to remember to add plus some constant to the end of that, because there could be any number there. A constant number. It could be 2 or 1.8 or pi, whatever. When I take the derivative, that's going to disappear because the derivative of a constant is 0. So this would be my g of x function that accounts for all possible constant values that could be there. All right, we've got one more example we're going to do in this video. If f double prime of x is 20x to the third minus 12x squared plus 6x, what is f? So if this is the second derivative, and I need to find f of x, then I need to take the antiderivative twice. So I'm going to go through the same process that I just went through. F prime of x is going to be the result of taking the antiderivative of this function, f double prime of x. So I know that this first term is going to have to be an x to the fourth. What times 4 will give me 20? Because when I take this derivative, I need to get this. And when I take this derivative, the 4 comes down and multiplies by something to become a 20. So what would that number have to be? Well, it would have to be a 5. And now I could do my check. 4 times 5 is 20. I would end up with x to the third. It's looking good so far. Minus, this is going to have to be an x cubed if I'm taking the antiderivative. And 3 times what gives me 12? 3 times 4. Plus x squared. And 2 times what would give me 6? That would be 3. Don't forget that when you take the antiderivative, there could be a constant there. And I'm going to call that constant 1, because you might see that if we do this a few times, we could get more and more constants, and we need to distinguish between them. Now I'm going to take the antiderivative of f prime of x to get my f of x function. All right, so we'll do this one more time. The antiderivative of 5x to the fourth is going to have to be an x to the fifth term, because that's got to go up by 1, so x to the fifth. And I want to bring that 5 down and have it become a 5. So all I need to be here is just a 1, because when this 5 comes down, it gets to stay. It doesn't have to cancel. Remember, in the derivative of this function, there is a 5 there, so this is perfect. I'm going to leave that as just a 1x to the fifth. Minus x to the fourth, same deal here. When that 4 comes down, it gets to stay there, because in the derivative of this function, there is a 4 as a coefficient. Plus x cubed, which works the same way as the previous two terms, plus, and I'm going to say c sub 1 x, because remember, there could be a value here. Now, if that constant was 0, then this is going to disappear anyway, but I do need to account for the fact that there could be something there. Plus another constant that could exist. So we've taken 2 antiderivatives here, and we need to remember that there could be other constants in that spot. So that would be your f of x function. So hopefully you tried that on your own and checked your work, but those are 2 examples, and you're going to have some practice problems to do based on this tonight.